When Hadoop actually started around 2009, 2010. 2009, 2010 to I would say 2014, 15, Hadoop was very popular. Hadoop is considered as a batch processing system. Batch processing system. But then 2015, 16, Spark introduced. When Spark was introduced, I think Spark came from Berkeley, if I'm not making a mistake. When they introduced this thing, Spark came up with the mindset that it is in-memory processing. In-memory. In-memory is always faster compared to batch processing. So what's the difference between Hadoop and Spark? The Spark can process in real time. So if you want to do real time, Spark is the answer. But if you want to process in a batch processing with some time wait, like example, few minutes wait or hour wait, then batch processing, Hadoop is the answer. So Hadoop is a batch processing. Spark is real time or near real time processing. Mostly people use for streaming. Very good. Now Spark has a very interesting thing. So people say when you use Hadoop, you don't have to use Spark. And when you use Spark, you don't have to use Hadoop. Technically, it is not like that. Spark complement Hadoop. Spark complement Hadoop. Spark can work without Hadoop. Spark can work without Hadoop, and Spark can work with Hadoop. So that is kind of nice. Spark itself comes with a lot of library. So Spark, first thing Spark came up with the library called SQL. So if you know SQL, you can work with Spark. If you want to do machine learning, you can do graphs, compute, streaming. There are a lot of things you can do. In Spark, mostly people use Java, Python, Scala, and R. I mostly work with Spark with Python. Now, the reason I'm telling you Python is so powerful, and I would encourage you to learn Python very well. And that's why Saturday class, which I started at 9 o'clock, no matter how smart you are, you can always repeat that. You will get a benefit. Python has two benefits. It works with Spark, and it works with IPython. IPython means interactive Python. Most people use it with the Databricks. So those who are going for data analysis, these are interesting concept, Databricks or Spark. These are all interesting. Whenever you use Databricks, Databricks also use Spark. So if you know Python, if you know Spark, you can work with Databricks or you can work with Hadoop also. IPython also very popular, but Python is the root. So if you don't know Python, you may not be able to work with Spark. You may not be able to work with the Databricks and all. Good news, in this class, I have already done a lab. So that is, I'm assuming you will do copy paste. I'm going to explain the concept about Spark because Spark is more, I would say, data analysis library. It kind of read the data and it process it. So it's very easy. It won't take a long time. So how it works? So Spark, everything Spark does in memory. So because it's in memory, it is considered as 100 times faster than Hadoop. 100 times faster than Hadoop. That's one. Second thing, Spark has three benefits. Hadoop only work with HDFS. Hadoop only work with HDFS. The storage has to be HDFS. Hadoop only work with MapReduce. That's the processing engine. So processing engine, MapReduce. Spark processing engine can be written in Java, Python, R, Scala. So it's a language that give you support language. Spark can work with Hadoop. Spark can work with the AWS. Spark can work with their own cluster. Spark can work with other cluster. So Spark is a cluster independent. Hadoop can only work with HDFS cluster. So Hadoop only work with Hadoop cluster, but Spark can use Hadoop cluster. Spark can use AWS cluster. Spark can use its own cluster. So cluster independent. And Spark also has storage. Hadoop use only storage HDFS. Spark can use HDFS. Spark can use S3. Spark can use Blob. So Spark gives you a lot of freedom. So you don't have to tie with one technology. That makes Spark more appealing to more customers because Spark you can use with Hadoop, you can use with the other cluster. So it gives you benefit. It also gives you storage, so you can use storage, different type of storage. Again, Spark is very simple. Now, another thing is when you are running in a Hadoop job, if job fails, so job may have a task, but if one task fails, you rerun entire job. In Spark, if your job and job has a task, and if one task fails, you only rerun that task. So Spark is very powerful. Spark gives you guarantee I can rerun the job and you won't have any problem. That's called fault tolerance. Spark does interesting things. So Spark has two types of command. One is called transformation command and one is an action command. So transformation commands help you to do all the work. And when you try action, then Spark will evaluate the transformation command and run. So Spark does two types of command. Transformation, it does not run. It just creates a sequence. When you run action command, then entire thing will run. So it gives you called lazy evaluation. Lazy evaluation means it gets time to think about it. How should I process? While Hadoop, MapReduce run each command, each task independently. While Spark runs all tasks and find out this one I should run first, this one second, this one three, this is parallel. So Spark has that ability because they use lazy evaluation. Spark uses memory, so it reuse the prior work extremely fast. And Spark supports SQL, so people like SQL. Spark is also kind of like Hadoop parallel processing. Spark is also used for big data. Any questions so far? Good. Okay. So you can see here, Spark is a language friendly, platform friendly. Spark can work with Hadoop. So Spark complement Hadoop. But Hadoop cannot work with Spark. So it's kind of reverse. So Spark can work with Hadoop, but Hadoop cannot work with Spark. Means Hadoop doesn't have directly connection with Spark. It's kind of bad, right? Spark can work with Kafka, Mongo, Java, everything. So Spark is a friendly, but Hadoop is only. So friendly only. So it's very awkward. So most of the company use Spark and Hadoop, but they use Spark more heavily because Spark is simple to install, simple to learn. Within a couple of hours, you can learn Spark. So how does it work? So if you see that Spark is 100 times faster, so naturally people will use it. Spark use data perspective, storage perspective, HDFS, AWS, S3, everything they use, blob storage. Spark also use streaming, right? And Spark is in memory distributed. So if you consider that Spark in Hadoop, speed of perspective, Spark means in memory. Now there is one problem. If you have large volume of data, and if your data require a lot of memory, the Spark will have limitation. So Spark can hold data till it has memory. So if your memory is, let's say, 20 GB, just an example, and your data requires 32 GB, then Spark will not work. So Spark will run, depends on your machine. So Spark need a lot high-end machine. Well, Hadoop can have old-fashioned machine. So they call commodity. So commodity hardware, Hadoop can work. But Spark need a latest and greatest machine because you get a speed. Most people who need speed, they invest money in Spark. Hadoop can work with the 10 years old hardware. Hadoop use hard drive for storage or intermediate. Spark use memory to process. So it's very important. So you can see this example. If I'm using Hadoop, so Hadoop process the data, and each time Hadoop process or peak process or Hive process, they write relation in hard disk. In the next process, again hard disk. So anytime you do hard disk in Hadoop, you are using I/O, and because you are doing I/O, Hadoop becomes slow. But if you're using what you call Spark, it all goes in memory. So you can see here, everything is in memory. Memory is always thousands of times faster than hard drive. Naturally, Spark is 100 times faster than Hadoop. Now, how it works? So first of all, Apache Spark comes with multiple libraries. One library comes with machine learning library. Second is Spark SQL, GraphX, and Stream. These are libraries. So streaming means your data is coming. So example, if you are getting traffic data, every second you're getting traffic data, that's called streaming. Or every second you're getting data from your parking meter or water meter, then Stream. GraphX, like example, if you have an airport and if you want to know how flights are moving from point A to point B. So if you have some kind of nodes and the direction, then GraphX works quite well, which I will cover next week. Next week, most likely we'll be able to complete this class. Make sure you are there. GraphX I'll cover next week. Spark SQL works with Hive and SQL, which is very simple as what we know, Hive. Whatever we do in Hive, Spark will use. So Spark can use Hive, Spark can use HDFS. Spark also a machine learning library. So example, if you want to do some kind of algorithm, you can do that as well. Because Spark uses Python, and whatever Python gives, Spark can leverage. Spark follow this language. Now, Spark also works with many scheduling software, like example, Kubernetes, Hadoop, Meso. These are cluster, Spark can leverage it. So Spark can use any cluster, and Spark can use any storage. Spark does not have a requirement that it has to be a. Spark can use AWS, Azure, Google, Hadoop. So Spark become choice for everyone because it's simple, it's flexible, it's easy to learn, it's Python based, it's lighter compared to Hadoop installations, and all setup is very simple. So now, how it will work? So first, it's a language independent. You can use any language we talk about. Second, storage independent. We talk about you can use any storage of your choice. And it is a cluster independent, means you can use any cluster, Hadoop cluster or Spark cluster or Meso cluster. So just as I thought. Now, in order for us to understand Spark, there are certain basic things you need to understand. So if I show you this picture, you will understand. So first is a driver program. There's a driver program. Driver program is the main guy. They will talk driver program. Every Spark program will use this called Spark context. That's a main context. That context will know how to talk to cluster because driver program say I have a job. Driver say I have a job. Then driver will talk to Spark context say what cluster you have. So cluster will have like example master node and you will have slave nodes. So these are the slave. So driver program will give a job and Spark context will find out which cluster I should run. Now cluster has let's example node we call worker node. Each worker node you have executor that take the job and from job it creates a task and then executor runs task. Executor makes sure it runs task and it stores the result. So executor has one responsibility. He run task and store result in a cache. Worker node is responsible to run the job. Executor runs in worker node. So every worker node has one executor. So you can see so the driver just fire and forget. So it fired, cluster will say I have multiple nodes, it will come and then it will, cluster manager will start distributing the task to this. Again, these are internal details. So now if you see this, it will make sense to you. Without context, you can't do anything. So Spark context, all program will need Spark context. It represents the cluster. So without context, you don't know how to run the Spark context. So you can run Spark locally, or you can run Hadoop, or you can run in Spark cluster. You can also say, I want to run with X parallel, X in the sense of like you can say, I want to run this task in 5 nodes, or I want to run this task in 2 nodes. So for there, there's a configuration file available. So using Spark configuration, you can say, you can configure, I want to run locally, or I want to run parallel. And when I run parallel, how many parallel I want to run? Worker node we talk about, they are just dual. So they are part of the cluster. Executor are running and it is run and stored data in memory. Driver is the main guy who provide the job. They use Spark context. Through Spark context, it gives to executor and executor run the program in a worker. Through Spark config, you can specify how many parallel jobs you can run, or are you going to run locally, or are you going to run parallel. Majority program, you will have Spark context. and you will have Spark config. If you don't give a config, it will take default config. So you will see that it's pretty simple concept. Any questions so far? Okay. Now, if I go further, there are certain rules to understand. So how Spark context works. So you can see here Spark context. First you'd say configuration, and you can say set master. I want to run 2 parallel threads. So if you specify 2, it's parallel thread. But if you say star, it means as many node available, as much parallel you can do it. So Spark config helps you how many different way you can do. You can specify, I want to run to Meso, I want to run to here, I want to run to Yarn. It means you'll use HDFS. If you say local, it can use local. So there are different ways you can specify configuration. It means your job, where your job should run. So you can have one Spark job running Hadoop, and one Spark job can run in Meso. That's the beautiful part about Spark. It does not have one dependency. So that's good. The configuration you are feeding to context. Through context, now you can talk to cluster. So cluster, you can see this Spark context talk to cluster, but cluster information came from config. So if you say 2, now this context will allow parallel maximum 2 job. So you can run 2 job parallel. So, or 2 task parallel. If you give 10, it will do 10 parallel, possible maximum 10. If you do star, means you're giving executor of choice, run as many as you parallel you want, depends on available resources. So sometimes you do star if you want to rely on the other thread. So here, run Spark locally as many worker thread possible if you do star. If you specify number, it will do according to the number max. Now, we talk about Spark as a library. Spark SQL is just normal SQL. Streaming is streaming. Machine learning library, GraphX. GraphX I'll cover next week, so please do join. It's one of the best concepts, so we'll cover that part. Now, as you go further, there are different languages you can use. Most people use Python or Scala. I use Python today, and Scala next week I'll use it. Again, you don't have to memorize. In this type of technology, mostly you do cut and paste, because the most important part is the how to set up this thing. Goodies are like 2 or 3 lines of code. Goodies are very simple, but most of the code are cut and paste. And that is why this subject is very easy. Many people write Python or Java program lifetime. They have to write a lot of complex logic. In Spark or Hadoop, their overall program will be hardly 20 lines of program. So it's not that complex. I added here a programming language in case if you want to read about it, feel free. Now, in order for us to understand Spark thing, there are a few terms we need to understand. So the first is called RDD. Very important interview question. RDD stands for Resilient Distributed Data Sets. So if you think about data, it's just like Excel file. Data is Excel file where your columns. So what Spark does, Spark creates these as a RDD. It means it will store into one machine this portion. It will store one in another machine. So it stores resilience. Resilience means if it destroy, it can recreate because the original is there. Think about that Excel is a sparse. Sparse means fragmentation. So small portion of Excel is stored in A machine, small segment of Excel is stored in B machine, and you are processing the data frame. Whenever I say data frame, is nothing but Excel. But Excel, if I store in one machine, please understand, Excel, if I store in one machine, then I can only run one machine. What Spark does, they sparse. Sparse means break into multiple segments. So that one Excel file, which we call data frame, they take 2 columns and put it in one location, 2 columns, another location, 2 columns, another, and they completely create RDD, Resilience Data Distributed Data Set. Why they divide into multiple machines? So now you can run parallel. If you have one data frame, listen carefully, if you have one data frame, then you can use on one machine. But what if I can say 5 rows and this column will be stored in one machine? 5 rows and this column will be another machine. So you can run parallel. And if you need, you can combine also. So RDD is a big thing in Spark. Spark, the biggest thing is RDD. So if you studied like Python, in there we call data frame. pandas, numpy, data frame. Data frame is nothing but Excel in memory. RDD, Excels are divided among multiple machines, so you can process. It's kind of Hadoop concept, HDFS. Your file, you divide the file into small segment and you run parallel. Here, instead of file, we call frame, data frame. You divide and put it in multiple machine, but in memory, so you can process. So it's very important. Without RDD, Spark is useless. So RDD is a distributed collection of data elements spread across many machines. And that's why it's very important. It creates into two different ways, parallel and existing collection. So whenever you have like data frame, and if you want to do parallel, you just say parallelize. So what happened? Spark will use this type of thing and store into multiple machine, and it will process parallel. So when you say parallelize, so if your data frame like this, please understand. But if you say this is a data frame, I want to do parallel, so Spark will process. This one will be one task. This one will be one task. This one will be one task. And this file will be stored in different machine. This file will be stored in different machine. This file will be different. So you are now doing parallel in memory processing. So parallelization means parallel. So example, if I have this thing, if I have this data, normally if you run like this, it's a sequential. But if you do parallel, this one will run in one machine, this one will run in second machine, this one will run in third machine, so you can do much faster. Next, so if you read any file, so if you want to read a file, you say Spark context text file, and this file should be HDFS or S3 or GFS or blob storage. You give a path, so you're reading the path and automatically it creates RDD. Everything in Spark is RDD, which is nothing but data frame. Those who have studied Python, if you don't know data frame, think about Excel, but in memory. So you can do that. Now, Spark has two types of command. One is called transformation command, and one is an action command. Transformation commands are lazy. Lazy means it does not execute automatically. So transformation commands are lazy. They don't run automatically. So there are 5-6 commands out there, not too many. Flat map, map, reduce by key, filter, sort by key. I'm going to show you with example. This will be a quiz tonight. We're going to cover that so you will understand. Flat map, map, reduce key, filter. There are 6 to 7 commands out there, which is a transformation. And action, we have now 3 or 4. So let's understand flat map. So what is flat map means? So example, if you have like a line, what flat map does, it creates each word separately. So flat map means each word token. So example, if you're spelling, a line, and there are words, wherever it finds space, it creates a token. It creates token. That's what flat map means. So if you have to like parse, like simple thing, then flat map may be better because each line, wherever there is a space, it creates a slice. Flat map is very powerful. You may like it because you will see everything will be divided into token. Map doesn't do that. So let's take an example so you will understand. It's a little confusing. So if you see here, let's say I have two data, laptop and phone. And here mouse and keyboard. Laptop and so now if I zoom map, then this one map will be like this: laptop, comma, phone. That's one. And mouse and keyboard, that's 2. So I have 2. So map both sides, so far so good. Now here, if I do collect, it will maintain as is. But if I do flat map, it will divide this into 2 tokens. So first token, second token, that came from here. Mouse and keyboard, divide that. So it divides each word into tokens. So you can see if I do flat map, at the end of the day, I get 4 right at end of the day. So flat map, here I have 2, but I end up 4. Sometime you may have 4, but you will end up 2. While map always have 1 to 1. So here you have 2, you will end up 2. So there are a lot of time in interview question, what is the difference between map versus flat map? So map maintain the association. Your source and target will remain same. So your input and output, it's a 1 to 1. In flat map, your input may be 4, output may be 8. Or sometime input will be 8, output will be 4. Again, depend on need, you can use. Filter, if you want to filter something, then you use filter. So filter means like example where clause in database. So you can use like this way, start with A if you want to filter something or contents with that. So there's one command through filter. So you can filter RDD. So if your data is going, you can say filter state equal to this. Then in RDD, if state equal to this, then it will create a new RDD. Every time you create a new RDD. So example, your data, and if you want to filter only newer, you can just specify newer, then here state equal to newer, then it will filter it. So it's kind of reduce by key. So let's understand this thing. This is very powerful. So example, I have data like this: A, apple, and B, banana, right? And C for cat. So this is called key, and this is the value. So if you want to sort by this, then this is the command, reduce by key. So example, if I have another A, just an example, and I say A for America. So what it will do is it will say A and A. So it will combine one key, and then it will create a list, Apple and America. This is very powerful when you want to do grouping. So it's kind of grouping. Reduce by key is a grouping. So think about in a database world, if you have city, and if you say group by city, here reduce by key. So city is your key. So Chicago, it will bring Chicago as a one key and all item in that. So once you have this item, you can apply max command, you can apply minimum command, you can apply sum, aggregation, and all. Beautiful. So reduce by key is nothing but wherever the key is common, keep one key and rest of the value put in a list. That's it. And sort by key, they are kind of similar, so I'm not going to go in detail. But then there is an action command. Action command, there are 4 commands are there. You can see here, count. So you can count how many items you have. So like example, you say reduce by key. If you say reduce by key, and you have 3 items, and if you want to count how many you have, if you want to find first item, if you want to say collect means get me all items, max, reduce, like that. So if you want minimum, so these are action commands. When you run this, then Spark program will run. So Spark program only runs when you run this action command. If you don't run action command, nothing will happen. So if you say RDD collect, so no matter how slice you have, it's going to get all data from you. And collect means bring all the data, and it will show you the final result. Just like HDFS does. HDFS, your data is distributed into multiple nodes, and when you say get me the data, it kind of merge and get you. So collect means get all data. So if you want to count by value is nothing but like this thing. So anytime you have count by value is like example, your key value. So the value is this one. So you kind of take this thing and then you count that. So this is the value, and the first one is the key. So you can do that one also. The first means it will get the first item from the, like example, we talk about A for Apple and A for Apple and A for America. And if your other item, if you say get me first or get me top 2, so you can get top 2 like that. So like that, you can say take, return the first number, or take ordered, or take sample. So if you have thousands of items, you can get some sample. So you can do that as well. All those things will happen in memory. So you can say top, like example, you can say get me first 2, top 2, right? And make string comma. So it will take 2 items and it will comma separately. Or you can say top 2 and then like that. So you can specify whatever RDD you want. Basically, you're what you call analyzing this thing. I'll show you with the example. And same thing, if you want to find out minimum, if you want to find out maximum, you can do the same thing. Right? So let's take this example. So here you got a file. When you read the file, it will create a multiple RDD. Multiple RDD, the reason we can do parallel processing. So once you have parallel processing, you can say count, it will count in each RDD and get you the result. So that's what count. First means you get the first and get the result. You can also do last like that. So these are the only commands available in Spark. Transformation command, map, filter, distinct, they are lazy load. Action, count means number of records, reduce, collect, take, these are action command. If you want to put it in memory, or if you want to write to the file, then command is save to file, which we'll cover after break. So right now we'll take a break. After you will see that. So I have like 6-7 labs to perform. Again, those are very simple. Within like 1 hour, we should be able to perform 7 labs. You can see that this how it works, right? In order for us to do all this exercise, the first thing we need to do is create a cluster. So let's get started and we'll create a Spark cluster. So we are in EMR. In case if you're not, you can search EMR. If you're not there, we're going to first create a Spark cluster and then we'll do some labs. So when I'm in EMR, so once I'm in EMR, I search EMR first. Please pay attention. I search EMR. Once I search EMR, I click on create cluster. The create cluster will help me to create a cluster. So when I click on cluster, the first thing we need to do is give a name. So today, this is my second cluster. So I'm going to say Feb 14 cluster. Just give a name. Make sure you remember the name. And this time you're going to select Spark. Make sure you select Spark because you do need Spark installed. So if you click on this, you will see that it will give you options that yes, it is installing Spark. You can see it does install Spark. Sometimes Spark installation does take time, but it's a good idea that you select the Spark. Now, rest of the things will remain same as a Hadoop cluster. So EMR cluster, just like that, no problem. So we're gonna, this time, we are not going to need it more than 1 hour, so I'm not gonna change termination part. Just gonna keep the termination as is, because 1 hour termination is good, because I think it's good enough, but if you wanna keep the cluster longer, you can change that. For me, 1 hour is good enough. Scroll down, and the keys, I'm going to use the key which we already have created, so we don't want to create a key. Good news, I have created key on Feb 14. So we can use that Feb 14 key. If you don't have a key, you do need to create a key and then use it. So good news, we have key. Now click on create service role here, and then we click on create instance profile. So this way we are good to go. And now create cluster. So only difference between Hadoop cluster versus Spark cluster, you selected Spark. That's pretty much it. Let it run. Please understand, when you create a cluster, first it will install Linux, then it will install Hadoop. After a few minutes, it will install Spark. So sometime you may see Spark is not ready. So don't cry. It may take a couple of minutes to install. Let it complete. While it is going through that, let me go back to our forum and walk you through. So first, I'm going to cover Python, simple Python concept, so you'll understand. So basically, in this exercise, x is 3, y is 5. So I'm going to print here through x and y. I'm doing addition, and I'm printing. Basically simple. So basically, any Python program. I'm not going to cover Python right now. We are going to cover more detail in Saturday class, 9 o'clock. But this Python program, you can give it to Spark, and the way you run it, write a program as a.py or whatever name you want as a .py extension, and you run through this way: Spark, lowercase Spark dash submit, Spark dash submit. That's your Spark program, and then space a.py. So any program you write should have extension .py. You're giving to Spark submit, which will internally read two things. What commands are transformation command? What commands are action command? So transformation command, it will do kind of workflow, sequential parallel like that. And action command will, when you have action command, it will run. So all command will run to this thing, Spark submit, and then your file name. So this is a pure Python. There is nothing the Spark will do that. That will give idea that our Spark is ready to go. If this doesn't work, you are not ready. So it's very simple. I'm not going to cover this part because this is just a simple program. You can write even hello world. You can write this thing and good to go. So I'm going to show you that. When you create the file, whenever you create the file, make sure you use VI editor. So we're going to create a simple file. VI like that, a.py, create the file, you insert by clicking I, cut and paste the code, save the file by escape, colon WQ. Once you save it, you come out and then say Spark submit, and then you write a.py and then run it. Spark is very fast. We'll see the result instantly. So now, let's see, Spark is ready. And we're going to click on our cluster. So when you click on cluster, just like you're connecting to the Hadoop cluster, you're connecting to Spark cluster. Please understand, Spark is quite faster than Hadoop, so you may enjoy it. So let's click on connect. And once you connect it, it will be lightning fast compared to Pig and Hive. Spark is very fast. Sometimes you may say, "Oh, what am I doing? It's how it works." So I'm in a cluster. I'm going to check here. So it says Spark submit. Just want to see it's there or not. So it seems like it's recognizing. It's there, so it's recognized. So that means Spark is good to go. So this way I can recognize Spark. Give me thumbs up if you're able to recognize Spark dash submit. Good. So Spark dash submit will enable you that yes, it is there. Now, in order for us to test it out, everything is working fine. What we're going to do here, let's do vi a.py. A.py is my test program. Py stands for Python. We press enter and we'll say I print hello world. Hello. That's it. Nothing special. Just say print hello. So we say print parenthesis. In parenthesis, we are saying hello. So this will print hello. That's pretty much we are trying to run. Escape, colon WQ. So now if you do cat a.cat a.py, you will see simple hello. Now if I want to run it, I'll say Spark submit a.py. And if I press enter, it's going to take a couple of seconds and you will see hello. Internally, Spark execute and you get the hello. Now, please understand this is just for testing purpose only. We have not used RDD. Spark program, only few things you have to understand. First, RDD. RDD comes from data. So any data files, you get RDD. In order for you to run, you need a context, which is called Spark context. Spark context talk to cluster, or it knows it gets configuration, and then you read data file. When you read data file, you RDD. Then you apply filter, flat, get count, max, mean, simple thing. That's all you need to do. And all those things are very simple. So it's not like rocket science. Please understand, think about your writing SQL command and you run the query. Here you're running, instead of query, you're creating RDD. In database, you create table. Here you create RDD. And then in database, you run select star from table where here you are using transformation command. So we'll see, and I'm sure you will enjoy it. So right now it's good to go. Let's go back to our forum. And if you scroll down, we did this exercise and we got the results. So we are comfortable. Now I'm going to cover this example. So how does it work? Please pay attention. And this is a simple program. I want you to pay attention so you will understand. First, we are going to use Python PySpark. So we are saying we import PySpark library. And from PySpark library, I need a Spark context. Why? Because I can talk to cluster. Then you instantiate Spark context and you're giving that instance SC. So now you have SC. Now you say SC parallelized. So this is the list. This is the list. And if you say parallelized, it means it creates multiple RDD for you. So example 1, 2, it puts here, and 3, 4, it puts here like that. So now your RDD. Now you're saying num take 1. So it will take the first and get you answer. You can do addition, you can do multiplications like that. So anytime you do parallelizations, whatever you get, that's the RDD. RDD is nothing but that's a data frame in memory. But data frame, it's not a whole data frame, it's a partial data frame. Because normally in Excel, you have multiple rows and columns. In RDDs, you kind of slice the rows and columns into multiple segments. That's why it's RDD. And you put in different machines. So each machines can run parallel. That's pretty much it. So in this example, if I read carefully, we are saying, first, I'm going to use library PySpark. From PySpark, I'm going to use class Spark context. These are boilerplate. All program will have Spark context. All program in the world will have. From that, you're saying parallelize. These are dummy data. Instead of dummy data, you will be reading data from HDFS, or you're reading data from S3, or you're reading data from other like Google Cloud or Amazon S3, or reading data from Azure Blob. So your data will come from different stores, and this command will create a multiple RDD. And here, just like you do take means get the first one. You can say filter, or you can say map, or you can say count, or you can say collect, like that. So process remains same. So always in a Spark program, these lines always there. This one will be context always there. So this is boilerplate code. Here, whatever you are doing here, these data file come from file or come from different source. And once you have that, you are going to create a RDD. And then from that RDD, you can create many RDD. So you can use multiple transformation command. Just like we create relationship, you can create RDD and you can do union, you can do intersects, and all kind of interesting things you're gonna do it. But for time being, let's copy this program, Control C, and let's go to our cluster. So we are in a cluster. This time we'll say VI, we'll say first.py. That's my first Python program or Spark program. Press I and right click and paste. Please understand, if you ask me in this program, this one always you will have, all program you will have Spark context. This one is reading this data and you are saying take one. Instead of take, if I say top two, then it will take two, top two. Very simple. So basically, once you have RDD, you are analyzing by using transformation command. That's pretty much it. Now you escape, save colon WQ. So you save it. Always double check first.py, make sure the program works. Once your program is kind of visible, you check everything is good, then you just need to run Spark, test submit, and you say first.py. And you will see it will bring me 1. Now a lot of things will happen. Again, in a real life, we can suppress all those things. These are log and debug. In real life, we only keep error. And you will get instantly 1. So it is processing, and it use all those concepts which I mentioned about. It use clusters, and very soon you will see 1. So if you see carefully, this is your answer. Right? So Python RDD stands for resilience distributed data set. Resilience distributed data set. So you get data sets which you are using here. So you got 1. Now you say, but I'm not enjoying this. What is this? Not useful. So let's some useful lab we'll do. So you will see that. So like in this exercise, please understand this one, what we have, please understand what we have, we use nums. So we created RDD. And now, because we are saying parallel, what if I can do square of each item? How do I do that? So there's a small logic here. Please pay attention. We say num map. Whenever you use map, it maintains the total items. So here items are 4. So map maintain the 4 items. So you're saying num map lambda, take one item at a time and multiply by that. So 1 will be multiplied by 1 times 1, 2 will be multiplied by 2 times 2, and 3 will be multiplied. So each item you're multiplying, and collect means then after you do that, get the result into this. That is your RDD, and now you're looping and printing the answer. So I'm going to copy this portion, Control C. So this is called parallel processing. You are doing parallel processing. The reason you are able to do parallel processing because this guy has created RDD. And now this one is doing map, lambda is doing square. So if you have a bunch of data, it will do, this one will be done by worker 1, this one will be done by worker 2, this one will be done by worker 3. And they all will do that. Once they complete, collect will get the data together and display to the client. So now I'm going to copy this portion, Control C, right? And go back to my cluster. Now I'll say VI. After last line, I'll press Shift A. Shift A means insert or I, whichever works for you. Right click and paste it. So basically, please understand, Python is a case sensitive. So I'm using this numpy. I'm saying map it and then say x times x. If I do 3 times, it will be q. I can do X plus X also, means I can do sum, whichever works. So you can do processing part. And collect means get all the result, get you the new RDDs. This is new RDD. And here you're iterating the RDD because the RDD will have parallel values. So you're looping this. So you have 4 items. You're looping that and you're saying %I means integer and you're printing num. So here 1, 4, 9, and 16 you should get because we are squaring. We are doing square here. Okay. So escape, colon WQ, press enter. Now, if you use up arrow and Spark submit, make sure you run the program, Spark submit first.py. It will run it and you will see the value. This is like a Python. In this class, Python is essential that you should have gone through the Python. Then you appreciate it. I know some of you have not gone through Python, so you may not get the idea, but overall, it goes through Python. So here you can see your answer is 1, 4, 9, and 16. Any questions so far? Or give me thumbs up if you're understanding what I'm trying to explain here. Good, very good. Good. So let's do some more interesting part, right? So if I go further in our forum, this forum is designed for simplicity. So now in this form, if you see here, what's the difference between map versus token? So if I do token, so if I have data like coffee, panda, happy panda, happiest panda party. So if I go to map, it will keep 1, 2, and 3. Whatever your input are, output remain in a 3 form. So you can create coffee panda, 1, happy panda, 2, and this. So it maintains 3 item 3. But if you do flat map, each item will be separate. So flat map either increase the result or decrease the result. But map maintain the result. So map keep this thing as a separate, keep this separate as a, but flat map does each item separate. So sometimes it's a little confusing, but if you want to understand, depends on the need, you can define it. Now SQL context. So what is SQL context? So if you want to run SQL command, so Spark can run SQL command. So Spark can run SQL command. So what happens? Spark can read data. Spark can read data. And when you read data, you get RDD, which is resilience distributed data set. And then you can run SQL command on top of that. If you want to run SQL command on top of that, you need a SQL context. If you don't have SQL context, you can't run it. If you have, let's say, Hive, then you need a Hive context. I'm going to show you a couple of exercises so you will understand and appreciate that. However, it's very important that you understand the context is nothing but it will help you to run SQL command. If you use a Hive context, you can run Hive command. So here, if I want to run SQL context, the first line, you have to import this SQL library. So you're saying row and SQL context. So you can see SQL context, this SC is nothing but Spark context. You're using that. You may say, but how do I remember that? You do not need to remember. In the real life, we do cut and paste, copy and paste. We don't type at all because these are called boilerplate code. All program will need exact same thing. There's no change at all. That's why learning Spark becomes easier because you mostly do cut and paste and modify only needed things. So here, if I have this thing, let me show you here. So whole program is here. So I'm going to walk you through the program. So first program, I'm importing PySpark, and PySpark through I get the class Spark context, row context, and SQL context. So I take these 3 classes. So this is the package, and from there I'm taking one at a time classes. Now first I'm creating a Spark context. That's the first thing. Always you will need. Now the Spark context I'm using in SQL context. It means I'm going to create a table, I'm going to create a column, I'm going to create a row kind of thing. So if you want to do like database kind of concept, you need a SQL context. Please understand SQL context you get from Spark context. And all those come from library, PySpark. So whenever somebody say PySpark is nothing but Python Spark. Okay. Now here I have created a list. So this is called tuple. Tuple means key and value. Key and value. Key and value. So I have key value. So I have tuple. So in easy language, if I draw this column, I have name and age. That's what I have, name and age. And name is John, age is 19, and Smith and 29. So that's what I have. So now I'm taking this and I'm saying, hey, Spark, parallelize this. So it creates RDD. So it creates like this portion is one RDD, it creates another. We don't know how many slices it will create, but it will create row column RDD, which is in memory. So now if you have 5 machines will get something. Okay, we don't know how it does, it's an internal algorithm. So now RDD is created. Now we are saying map lambda X, and we are saying create a row. Please understand, create a row. The first item will be name. So this item will be name. We say X0. X0 is nothing but this X0 means first key is your name. And the second will be age. So you are creating now heading. So name, age is the heading now. And then you're going to add this thing. John is the name and age is a 19. Smith is the name, like that you are creating. Once you have done this, you're saying create data frame. So you're creating data frame. Now, please understand, when you try to do create data frame, sometimes it may ask to install Panda or NumPy. Sometimes it may ask, because if there is no library there, it may ask. Good news, I'll show you how to install. That is not easier. So you're using this RDD and you're saying create a data frame. So now you're creating data frame and you're using SQL context. SQL context create data frame from RDD. So you're passing RDD, but you're getting data frame. So what is data frame? In memory Excel. Data frame means complete in memory Excel. So you have data frame with name and column. So it's in memory. Now you can run the command like that. Data frame show me schema, and you can say data frame show me 3 records and truncate false. So you are not truncating. So you show me 3 records. So here 1 record, 2 record, and 3 records. So I'm going to get 3 records. So here you can see so, and you can say 3 means 3 record you are showing. So technically, it's just like, you're using their clause and you're trying to get data. So now what I'm going to do, I'm going to copy this program. This is much more powerful. So it gets me this thing. In a real life, the only things will change here, please pay attention. In real life, this will come from a file. So your file will have columns. Yes or no? Those columns, when you read that, it's going to create RDB. Now let's example, you have 4 columns, right? 4 columns. Then here you will create column 1, column 2, column 3, column 4, column 5. And then you have this thing. Then you create data frame. Once you have, then you run all the commands. You can also run a pure SQL command also. You can run select command also. I'm going to show you also. So that's all Spark is about. Basically what it does, it's a wrapper. Just like Hive is a wrapper on data, Spark is also a wrapper. So Spark creates Spark context, and Spark context gives you RDD in all machines. You don't have to go to machines. You just tell Spark, run this thing. It will run to its RDD and get you result. Behind the scene, how it works, it's a secret. And that is the reason people love this Spark, because it's so simple, right? So now I copy this thing. I'll go to my instance. Let's create a new file. So it's a vi second.py. And I say insert I, right click, and I paste it. So please understand, right click and paste it. Here, this is my data. I'm using hard-coded data. But next exercise, I'll show you how I push data in HDFS, and I'll read the data from HDFS. I'll do processing, and I'll write data in HDFS. And if you know that, you're good now in Spark. Rest of the thing is a Python program. So if you want to do anything massage here, any logic here is a Python. But if you know Python, you can do all the logics and you can write your custom functions. You can do all those things. So Spark itself has only 9 commands: transformations and actions. It is a wrapper. It's a wrapper, and wrapper allows, like example, when you use SQL context. After SQL context, you get the data frame. Then you can use all your select statements. It allows you that enablement, and that's why you can leverage all your SQL knowledge working with Spark SQL context, or you can use Hive context if you want to use Hive command. Right? So right now, escape, colon WQ, I write it. Now I have this file. I'm going to run this. So Spark submit second.py. Please understand, whenever you create the file, now you run this file, you always do Spark-submit second.py, press enter. It will take a couple of seconds and then you will get the result. in this result, I should expect 3 records as output because I'm saying show me 3 records. That's what our intention is. So at the end of the day, I should see 3 records. So first it shows schema, which we saw schema was done, and here you go, the record. See how nicely it shows the record. So data file was in a list form, a tuple form. From there, we created a column. You can see the custom column we did, and we got the 3 records. So now think about if any data you have, Spark can bring it, and now you can run the SQL command. Pretty easy. What do you guys think? Right? So let's do some advance in that. Right? So if I go here, this one will be interesting. You may like that. In this command, we are creating a file, and this file will push it to HDFS. We'll put it to HDFS. And then we'll write a program to read this file and count how many words you have. I want to count how many words you have. So example, anytime you have same word, then you count 1 plus 1 plus 1. So you will count. So entire exercise works in multiple steps. First, we're going to create a file. Then we'll put this file into HDFS. Once we put the file in HDFS, then we're going to read this HDFS file and we'll do that. So here I have concept, so you will understand. So first, you use the library, create a context. As I said, this boilerplate. Now using Spark context, you're saying read text file data. This data has to be in HDFS. So from HDFS, it will read and it will create RDD. Now we are saying from this RDD, flat map, lambda, line, split. Whenever you have space, split it. And then map lambda, word 1. So you are counting each word as a 1. And the reduce by key. So if there are same key word is there, then you're going to add these 2 items like this. So you're adding this item. So this way you're going to calculate it. And once you are done, the final result you're saving to output. This is awesome. So let's understand how it will work. So please understand, whenever you have file, it will go like this. So you read the file in HDFS, it will be like this. This is a text file. Now that text file you created RDD. So RDD means multiple things. Each RDD you're gonna do like split with the space. So when you split the space, so each one will calculate its own word. So example, A is 1, I is 1, like that. This one is the A is here, that's a 2, 1, K is, that's a 1, like that. This one is a C is 1, like that. And then it will keep doing that. And then you can say this all A go to one place. A1, 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 it comes in the same place. Like here, B, B1, B2, it will come to same place. And C1, C, and then they will add together, and then collect will get the result. And once you have result, you store the result in HDFS. So here you can see here, first it will calculate A1, each word 1, each word 1. Then based on the key, it will route. So example here, you're routing all A here, you're routing all B here. So you can see A are here. This one is 2. So because this one is 2, so 2, and I can say 1 plus 2 plus 3, this is 6. So key is same. So this is called reduce by key. Reduce by key means you are using key same, and here you are adding. So reduce by key means this. When you say reduce by key means keep key is same, which group, basically reduce by key is the group. And here you're saying B, and you can see the calculator. So in this exercise, we have 4 or 5 steps to follow. This one data file has to be in HDFS. Then your flat map means you're splitting. Then you are counting word and reduce by key. So this is the entire thing you're writing in one line, which is ultimately going to give you RDD. And that RDD you are saying RDD save as output. So when you say save output, it will be saved in your HDFS only. So let's do this exercise. If you ask me, this is the hardest exercise because 99% you will be working this type of exercise. You have data file, which is HDFS. You do processing. This you may expand as you go further, and then at the end you store the file. And your always context will be Spark context. In the middle, let's say you want to do SQL context, then you write here query. That's pretty much you will do. You read the file, Here you're reading file from HDFS, you process the file, you do query and all analysis, and then final RDD, you're going to save. If you do the save, that's a file. Read. So your input says processing. In case if you are not very clear, your ChatGPT can also help. You can write that. So like example, in case like I have RDD, right? I'm going to show you so you'll understand how easy it is. So like example, you have RDD, and let's say you want to filter something. So like example, provide Spark, right? Python, RDD filter, comma, and loop, and display the result. You write in English, you will get that information. Make sure you understand the concept. Majority people do not know the concept, but you can see this is beautiful. So here your Spark context, you're saying local means I'm going to run local. This is your data. It can come from file also. Once you get the RDD, you filter, and you are doing all those exercise. Now, instead of this Lambda, you can also write your own Python program, and you can call that. So that's a beautiful part about Spark. Spark allows you to write Python program. And in your Python program, you can write if statement, for loop, and all, which I'll be covering in this Saturday, 9 o'clock. So you can write your own Python logic. You call it, and then you get RDD. Once you get RDD, and then you display. So you can get all those things right away. Please understand, most people can get these, but they don't know how to create a EMR Spark cluster. They don't know all the steps. They don't know how to run Spark submit, right? So that is the problem. Until you know step by step, you will be invaluable. But getting code or getting book, Google, there are a lot of things you can do. But running this thing, that is where you come in picture. Make sense? So right now, we will do this exercise so you will understand and appreciate. So let's do that. So first, I'm going to copy this, go to my cluster. I'll say VI data, and I for insert, right click and paste it. So I have this, and I'll say escape colon WQ. Now get data, making sure we see the data. So I have data. So the data is there. Now I'm going to put the data to HDFS. So Hadoop FS put data to HDFS. I normally don't type in a real life. I also command paste command. So you're saying, hey, my data file is local. I want to put it into HDFS. So it will be stored as a data file. So it's done. Now I'll go here and say, now I'm going to run a program. So if I want to run the program, I will use this thing. Please understand, in this exercise, this data file is coming from HDFS. So which we have already stored. So now it's a VI her.py. That's it. Insert. Now right click and paste it. Everything looks good. This is our library. Spark context is there. Use this, read the file. If you want to read a particular file, you can give a path also. User, root, data, you can give path. You can read multiple RDD and create a join also. So there are joins available also. You can do union also. You can combine that. It's just like a Power BI or SQL does. You can also join and get column from here, column from here. All those things you can get through RDD. So RDD operations you can do also. Right? Now, escape, colon WQ, and enter. Now it's time to run Spark submit her.py. So at the end of the day, it will create output file in HDFS. You will not see the result because result is stored in output. So if you want to see the result, we need to run HDFS command to see what you have in the result. So result is supposed to be in this file, whatever the words you have, it is going to count word. It will count word and number of times the word is repeated. So that's what it's going to do that. So if you complete here, it's completed. You see result is not visible, but if you run like this command, Hadoop fs -get user root, and the file name is output start. So here you will see it will show the word and count. Give me thumbs up if you're able to understand how it worked. Good. This one, if you ask me, writing this thing in Java approximately take 400 lines. Writing this thing in Spark, only 1 line. And it is cut and paste. The power of Spark is significant. Whatever I'm running, if I have a large file, significant large file, you can still do that. So if I have a large file and if you want to process, it will work the same thing, no matter how complex file you have. So I'm just giving a sample file, but if you have billions of rows, it will work exactly same speed. And that is the power of Spark. And larger the file, still your time, it won't take longer because everything it does in memory. Good. So now let's see which one I can show you. So this one is like which we talk about join, right? So if you're RDD, you're getting RDD, you're getting RDD. Now let's say you transform RDD, now you want to do join and you want to get another RDD. So let's see a simple exercise here. So in this exercise, we are saying X range. X range is nothing but get me 20 values. So it's going to get me random 20 values. I think it's take 1 to 20, my mistake, 1 to 20. So it's going to get me 20 values. So first it will get me 20 values. So it will say 1, 2, 3, 4, like that, right? Now here we are saying filter this value, lambda X mod 2. Mod 2 means if you divide successfully, then it's an even value. So I have, it's supposed to be even here, my mistake. And this is supposed to be odd, doesn't matter. So I'm creating two RDD, one RDD, which is divided by 2, and one RDD divided by 4. So what I'm trying to look for is what is common, what is unique, like that. So you can see I'm doing union, and I'm printing here. I can also do intersect. Intersect means what is common. I can do subtract. So what is available in first RDD, not available in second RDD. This is beautiful. This is just beautiful. Why? Because you can play with the multiple RDD. In a real life, you may have multiple files. And if you have multiple files, I'm giving you example here hard-coded, but instead of hard-coded, I may read file 1, just like previous example we read, and we create RDD. Then we read a file 2 and create RDD, and then follow the same command. This command will be same. This portion, I'm doing it just for demonstration purpose, that you can have multiple RDD, and then you can do init. But in real life, your files, you will read files and create RDD. How to read that files and create RDD was this example. So here you run data. If you say data 1, create file, data 2, create a file, data 3. Once you have RDD, then you come back here and say whatever file you read, right? That first file union with the second file. And same thing, if you have a third file, you can keep doing that as many files you have. So in this example, I'm going to copy this one and control C here. And let's go here. Now VI, I'll say this is my program. .py, insert, right click and paste. Always try to read the program and try to understand. So you will understand first line is always PySpark. The second line is Spark context. You're saying local, means you're running locally. This one will generate 20 lines, 1 to 20. This one will say, if I can divide this file in the value by 2. So 1 is not divided, but 2 is divided. So this one will say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It will take 2 divided by 2, right? This one is a 4. So it will take 4, 8, 12, 16, and 20. So now if I say what is the duplicate, then this one is duplicate. It exists here. Which one is unique? So you will see you are doing difference between these two RDD. And that's what union means, try to bring all. So this one will bring this one. But if you say intersect, then you will see this. So let's see that, so you understand. So escape colon WQ. WQ means write and quit. Now learn it. Spark, submit, fifth dot py. When I had a first opportunity working with Spark, oops, there is a problem. X range is not defined. X range is not defined. So I need to see anytime you have this type of thing, X range is not defined because it's not finding the X range. So my best example here, I'll say fix it. So it's gonna give me somewhere I missed the library. So it's a range. So it's a range. So I need to use range. Okay. that was range here. So small issues, fix it. Don't cry, fix it right there. So here it's a range. Range, I'll say 1, 20. See, I am explaining all those things, and you can see right now how fast it works. This one is getting this result, right? And this one is, as you go further, your answer will be here. And you can see this one is intersect, right? If you go up, you will see another RDD. This is the RDD, which is union. Make sense? So if you want to do merge, just like you do in database, you do join, left outer join, right outer join, same concept. There's nothing special. So in database, you're running query against database. Here, you're running query against distributed files, and you're leveraging large cluster to do the same thing. So if you know database join, you know what I'm trying to explain here. Good. So let's do one more, and then we'll do quiz. Right. So I completed this portion. So now let's do this one. Which one is this? Yeah. Yeah, this will be interesting. This is interesting. You may like it. So this file is a CSV file. Okay, it's a comma separated file. We are creating a file called data1, and then we copy this file into HDFS. So first, we're going to create this file CSV, and then we're going to push this file to HDFS. Once we push the file HDFS, we are writing a program. We are saying first create a Spark context, and we are going to say local, and then here we are saying read this file. Whichever file we push it, read this file. In this file, you are saying Spark context text file. You're reading this file. So this one will be your RDD. This one will be your RDD. So please understand, whatever your context you create, that context through you read the file. So now it's RDD. Once RDD is there, you're saying lines, map, and you're splitting the line whenever it's a comma. So now your parts. So you're going to get parts. Parts means token. So you got a token. Now you're saying first line has a header. First line has a header. So you can see here this line. So I want to remove that basically. So that's my header. So you're saying first line is the header. So I'm going to say filter the line header. So when your header line is, filter that, and that's your data. So now your header and your data. Now you're saying data map, lambda, first column will be number, second column will be name, third column is the age, and fourth column is city. How did you know that? We are saying here, the first one is number, name, age, and city. So that's what we are doing. Got it. So once we have that, that's the people. So we created a people. Now we are saying Spark, create data frame people. So this is your data RDD, you're passing RDD, and from RDD, you are going to create a data frame. Once your data frame, we are saying create or replace temp view. Temp view means memory. In memory, we are creating this in memory. Now it will create a table in memory. This table name will be people. Now you can see Spark SQL, select name, because name is the column, age is the column, city is the column, all those columns. And from people, this is the view you created. Now you can use where clause and all. How beautiful it is. Now, this one, run this command on your view which you created, and you get a RDD. Now this RDD, whatever you want, you can display, or you can loop it and you can print it like that. Can I run any SQL? Any SQL you can run, as long as this is in memory, it will be lightning fast. So if you see carefully what we did, first we are pushing this file. First we are pushing this file to HDFS. This file is comma separated. Once we push the file, then we say, oh, Spark, get me Spark object. So we got a Spark object. And using the Spark, I'm getting Spark context, text file, I'm reading CSV. So all lines I get. I know the line has one header. So first we are saying, you know what, split it. So when you split, you got a parts. But first one, so we got a first one is the header. And we say, you know what, filter out that. Filter out, if it is not header, those are data. So we got a header and we have data. Now using this data, we say, you know what, data has a lot of parts. So each part, the first part is in the, this is the column name. So this is the column 1, column 2, column 3, column 4. So we get a column 4. Now this is in your memory, people. Now you're saying create data frame people. So you got the people. And that now once you have that this schema people, you're saying everything is schema is created based on what you specify here. So schema means nothing but table structure you created. Now you're saying schema people, create or replace temp view people. So now you're giving name. Can I give any name? Yeah, you can give any name. Technically, this is a table name. Once you gave it, now you can run query. And then once you run query, any output of the query will be always RDD. So you get the RDD and you can play around. So you can print it, you can loop it, you can store in a file also. So here, I'm going to copy. Let's start with here. This is our last exercise for the day. So Control C here and press enter. VI, this is my 6.py. Press I and right click and paste it. Anytime you have space, please press DD, escape DD, so you can remove the space. Sometimes Linux command is very powerful, so we do that. So I save it. Now my file is there. That's my mistake. I should supposed to use data one, right? So let me rename that. 6.py is a data one. .csv, right? Because we are trying to create CSV. Sorry for that. Data one.csv. Now this data one, I need to push it. So this is the data one CSV I need to push to Hadoop, which I already have command. I'm going to paste that command and push it. So that's a file is now pushed to HDFS. Now I need to do vi 6.py. That's my program, Spark program, and I'm going to do that. All those heavy lifting I have done. Please understand whatever I'm teaching right now, it's if you don't have this thing, it's going to take months to do that because each and every command takes time. I have done the simple lab. I have documented here everything you have in the forum. You just need to copy, paste, and run. In a real life, you get a lot of times to do this exercise. Even though whatever I'm doing cut and paste, normally people spend 10 hours, 15 hours to do so. You have everything ready, you just need to run one time. EMR makes very simple. If you don't have a Spark cluster, you can't do anything. Good news, Spark cluster makes very simple to run. So I have program, good to go. Run it, Spark, that's submit, and 6.p. I really like EMR because it's so fast. It's like you can 3 minutes, you create a cluster, run it and destroy it. So you can see that my table, I got the data, name, this thing, and schema is created. So how did I get this thing? So if you notice that, if I run Hadoop, fs -cat, right, user root, file name was data.csv, then you will understand what we are trying to do. So I fetched, so you can see a Tom, Ron, and Rina. So that was Tom, Ron, and Rina. So how did it happen? So I gave a where clause. So let's see here what where clause I gave. So I gave a where clause where age has to be between 30 to 49. That's the where clause I gave. So now, if I see here 30 to 49, so this one is definitely, this one is definitely, and this one. And these are three. And that's why Tom, Ron, and Rina we got. And here we go. Tom, Ron, and Rina. Make sense? So here my Spark related activity completes. Next week we'll complete this whole course. So make sure you attend. I'll do a little bit GraphX, and I'll cover like other things which I have not covered, like the Zookeeper, HBase, and Scoop concept. But let's do a quiz. Let's see if you guys can participate. You guys been quiet. Let's see what is the correct answer here. What would be the correct answer here?
Big data processing.
Big data processing. Very good. That's the correct answer. Let's go to the next one.
MapReduce.
Storage, right? Distributed storage. MapReduce is not a storage.
Oh, I see. HDFS.
HDFS, yeah.
Next one.
That's the role of things.
Remember we say like each worker node, you will have executor, and there are tasks.
Run task and stores.
Run and store. Run
Yeah.
in a cache. So it runs and store in a cache. So this is the correct answer. What is Spark config is used for?
Configuration. To define data frame schemes.
It's configure Spark application.
Oh.
Right? Because data frame schema is a context to execute transform. No. In looks configuration, give a config. So configuration gives you, do you want to run local or you want to run remote? You want to run against Hadoop? You want to run against Meso? You want to run against Spark cluster? Do you want to run one thread or you want to run multiple thread? That's the configurations can give you. Right?
Parallel processing.
So parallelize हमें like create always RDD. Parallelize will create RDD. Parallelize will create a RDD from a local collection. So see here, RDD is nothing but resilience data distribution data set. It's kind of, Excel file slice into multiple machine. That's all. Spark, if you ask me, the most important part in Spark is RDD, because you're processing entire data in memory. Flatten the list means each and every token will be separate.
Flat map.
Yeah.
Good. Which Spark transform used to filter element in a RDD?
Filter.
Correct. So if you want to filter, let's say A, filter B, filter state, filter country, filter name, then you use filter. What is sort by key means?
Sort by key. Sorts the RDD based on keys in key values pairs.
Correct. So anytime you A for apple, B for banana, C for cat, it use this key, sort by this, and then it adjust. Action. So there are 4 commands for action. So collect is the one thing, take is one thing, collect is one thing, take is one thing, save as is one thing. There are 4 command or action command. So collect is one of them. Right? These are transformation commands. Transformation commands does not execute. But when collect command comes, save as command comes, take as command comes, then all previous command will run. So these are lazy commands. These are transformation commands. So sometimes they say, which are lazy? Lazy is a transformation. You don't run it. You only run when you have an action command. So action command is correct.
The count action is returned. Some of the elements in an RDD.
Total number of elements.
Count. Sum means you have to sum, like, in that case you need lambda, right? You need to sum. Max mean you can get right. This is most likely total number, right? Because you are getting the count.
What does the first action do? First action stored RDD.
Returns first n elements.
This is like a top command. Like how many, like out of this RDD, which one you want? First 5, first 1. So n is number. So how many records you want to report? Returns.
Largest element.
So anytime your RDD, right? Your RDD, and you can say, no, what, get me the maximum value. It will get you maximum, minimum, like that.
A collection of identity.
Data frame is not a collection of identity.
Okay.
A distributed table-like structure.
Table-like structure.
What is SQL context is used
SQL.
for in Spark.
To exhibit from
So to
Yeah,
process.
process structured data using SQL queries.
So that's why you can do that. The last one.
Hive complex and Hive query.
So if you have Hive context, SQL context will go to Hive, and then Hive can run Hive query. So I think this most likely,
Second.
Yeah,